Hello everybody, welcome back to the workshop. This is part 2 in a two-part series. In part 1 you saw me mill the face on the bottom of my vise here. This is the fixed jaw on a bench vise, and I also drilled these 4 holes and tapped them M8, and we also went through procedure to pull one of these apart, how to get the movable jaw and the screw out. Today we're going to be machining this plate. We'll be drilling these 4 holes and countersinking them so that these M8 screws fit in them nicely, and then we'll drill these 3 holes. I'll just pop the back gears in. That locks the spindle so it can't turn. Supposedly. These have got a screw-on chuck. Pop that under there so I can't damage the bed. This 3-jaw chuck won't go big enough, even with the reversing jaws on here, or the reverse jaws. If I try and clamp around the outside, they're not held in the scroll in the inside of the chuck far enough to make it secure. And with them all the way in, the jaws won't fit inside that hole either. It's very close. I might be able to use that later on if I want to clean up the outside diameter, but that'll just be for appearance, won't really matter. So I'll put my 4-jaw chuck on there. You can see here, 4-jaw chuck's slightly bigger in diameter, and there's a fair bit of the jaw still engaged with the thread, and this part will fit there, and with it firmly against the back of the jaws, it still gives me enough room to take a clean up cut, and the jaws are out of the way in there, so I can take a cut across the bore as well and clean that up. None of that really matters, but it'll make it look nice. Now these jaws all move independently of each other, unlike the 3-jaw where they all move together. So this is called a 4-jaw independent chuck. And the other one is a 3-jaw concentric. I had the jaws lined up roughly equal before, so now with that in there just loosely, let's see how close we've come. I'll just reach in front there, excuse me. This is my scribe block. Again, this doesn't need to be super accurate. I can either line it up with the hole or the outside. We'll try the outside first. We'll just line that up so it misses the jaws. Maybe I get it at about centre height. We'll just find where the high spot is. I can hear it touching here, so the part is this way a little bit. So we'll loosen that one a fraction and tighten this one a bit. Should miss now. Just touches on this one now, so we'll loosen the other one, tighten this one. Let's just have a look at how the middle is now. You can accept that. I'll just make sure it's tight all the way around. I'll also just make sure it's hard against the the back of the chuck. I can't see any light between the jaws, maybe a fraction there. Give you a closer look. We're looking to see whether it's riding up and down like that or whether it's turning in and out like that. Mind you, it's just a rough surface. It's like a flame cut on the outside, and it's been oxy cut out of a plate, I'd say. So what we're going to do now is going to face off down here and bore it out down there, and that way it'll give us a nice clean face here to clamp the vise to. Doesn't really matter about all the other stuff. It's that'll be just cosmetic. Here's the turning tool I came up with the other day. I showed you how to make. It's just high speed steel. We'll make sure it's still on center height. I know my lathe is exactly 5 inches from the top of the bed to the center of the spindle. It's 5 inches. And we'll just give it a bit of clearance on the front, or on the side I should say, like that. If you look at the tool now, it's got a little gap down this side here, and that'll stop it dragging. It's only going to cut on the point. I might need a bigger radius on this tool, seeing as how it's a black surface, and there's going to be a fair bit of difference in the surface speed from out here to all the way in there. Let's find out what happens. Often the surface speed requires a slower RPM than what you think. If I want to get this run at about 80 or 90 feet per minute out here, I need to slow it right down to about 70 RPM. I've got a 69 on this, but I do need to engage the back gears again. I have given a demo on that before. We need to pull this pin out from in there. The machine actually has another screw on the other side that it's a screw in. I don't know whether you can see that down in there. But we'll pop that out as well. Alright, that's got it. Now the spindle turns free from the gears, from the pulleys, and if I engage the back gear, like that, now it will turn really slowly. Let's see how that goes. Make sure nothing's going to fly out and hit me. That noise is the back gears whizzing around. Just touch it off there. Wind out till it clears. Bring it in, say 15 thou. Let's try and get under the scale there. Didn't quite clean it up, but I wasn't really expecting it to. It's closer than I thought it would be. see how my tool is looking there. Not much air left in the tank. Let's just give it, it's not too bad a finish, let's give it another 5 thou and we'll just let it go. Alrighty, that'll probably do. Not fabulous, but all we really need is for it to be flat. And now I'll just put a boring bar in and we'll clean up that centre hole as well. This is my little high-speed steel boring bar. It's just a piece of square, and I've ground it along the bottom here to give it some clearance for the radius of the bore, and the cutting edge sticks out a little bit further. The usual, you can see it there, the usual front clearance and rake ankles and stuff. It's the same thing as I've done on my how to grind a turning tool video. It's just all done around the other way for a boring bar. It can bore up to that deep, and there's clearance on the bottom, so there's no point in me clamping it anywhere up near there. So I'll just stick it out about that far. We'll clamp that down. It's about 1.5 inches. Yeah, that's pretty good. Touch it off in there. We'll take about 20 thou on the dial. That'll be 40 thou on the diameter. Feed going the right way. This is about 6 thou per revolution on the feed. I use that for all sorts of stuff because it's a pain in the ass to change. That's out the back. Go another, say 10 thou this time on the dial, 20 thou on the diameter. Give it a bit of juice in there. Hasn't quite cleaned up there yet. I'll just measure that now, and we'll aim for a size in whole millimetres somewhere. That's about 36.7. We'll take it up to 37, so I'll take another 0.3 of a mil. 0.3 is about 12 thou. Maybe that'll clean it up, maybe it won't. It's got a bit of a spring on it as well. Looks like it's got about 8 thou of spring on it. I'll just let that feed back out again the other way. That'll reduce the amount of spring on the tool. And we'll see if we've got a hole size there. Doesn't really matter. It's not quite cleaned up yet. I want to measure the swarf. Yeah, that's 36.9, so it's nearly 37. How about we take another 1 mil off? 1 mil is 39. We'll take half of that. We'll say 20 on the dial. There's 10. There's 20. I'll just let it feed back out the other way. Hopefully I'll be 38. Which it is, within 0.1. Doesn't really matter, but it's always good to practice. Don't need our boring bar anymore. We can put our chamfering tool on. Let's just see if I can put a chamfer on the outside up here. Maybe this tool won't come back far enough. Oh yeah. Okay, that's looking pretty good. I've got a nice surface there. This is just a deburring tool. It's an old triangle file that's had a point ground on the front of it and the rest of the teeth removed along there. You can just go along here. Always be careful not to stab yourself and take the sharp edge off. Now what I'll do now is go over into the mill, mount this up, and we'll drill 4 holes in there to match the pattern that I drilled in the bottom of the vise before. I've got this plate set up in the mill ready to drill my 4 countersunk holes. Just going to line up the chuck over the centre of the workpiece here. I've got this thing, it's called a wobbly pointer. Really handy for finding centres and pointing at stuff. You just pop that little ball inside the chuck and tighten up that there. Doesn't need to be real tight. I got this thing on eBay for only a few bucks, so I'll show you how that works. Yeah, wobbly pointer. So that goes up inside the chuck, and you can tighten him up. I'll just let it up a little bit there. When I start it up now, you'll see it's wobbling all over the place. It can be wobbling around like that. All you can do it with a ruler if you're not comfortable with your finger. You just bring it down, just touch the point, you can get it running true. Now that's pointing to exactly the centre of the spindle. And if I wind that down there, or bring that down and point it to the edge of my hole, edge of the hole is the hole is actually 38 millimeters diameter. So now I'll just come across 19 mil, which is half of that. I'll set my 0 there. This dial has lost its knob, so I need to make a new knob for it. So I can lock my cross slide again, or lock the table, really the cross slide. That's looking like roughly the middle of the hole, but I haven't done it on the other axis yet. That's pointing at the edge there. So I'll set my 0. I want to come at 19 mil. Like that. There we are, back on the centre of the hole. Now I just need to wind it out by half of the pitch in either direction, and I'll be in my spot to do the first one. I'll just speed through that and bring you back. You don't need to watch me turning dials, but that gives you an idea how you do things without a digital readout. Just check I'm not going to drill my parallel block back there, but it's a long way clear. Here's my squirty can. This is just an 8.5 mil drill for clearance on my 8 mil screws. Great camera work there, Dave. There's a bit of a debate whether you move from hole to hole and use each tool once, or change tools from one to the other. Personally, I'm a change tools guy. That doesn't really matter either way. Now I'm probably going to need to go a bit slower for that. And based on that, because it's a pain in the ass changing speeds, I think I'll go from hole to hole and just center drill it, and then come back and do the chamfer. Next we'll put a chamfer on there, big enough to sit my little bolt flat with the surface, or actually slightly below. Here's my chamfering tool. These things work really well. I find the older style one with the teeth around the edge like an end mill don't work very well. They chatter very easily. These usually cut a great finish. Let's see how I go cutting such a big chamfer. Generally speaking, when you're working on cutting on big broad surfaces, the slower the better. So I slowed the mill right down. That's as slow as it goes. Let's see how that goes. Once I get my desired depth, I'll set a stop so I can make all four the same. it's going. Not quite, but almost. A little more. A little bit clunky. Yeah, it's still a bit proud there. I'll just go a bit more. Try it with the wind down quill feed. Yeah, that's below the surface there now. So let's just I'll make sure the chuck's nice and tight so that it can't slide up inside the chuck. Okay, should be able to make all four the same now. There's my 0. I'd know if I was 4 mil out. So let's do the next one. Yep, that's below the surface. Alrighty, I'll go around the next 2 holes and I'll bring you back. The only thing left to do is to drill a couple of mounting holes in here so we can bolt it to the bench. To do that, I'll just mark it out on the plate here. So I'll put the 2 machine surfaces together. No crap in the way. I actually only had 3 of these screws, so I had to nick up the shop and buy some more. And the ones they sold me were stainless steel, but that's alright. Just line them up there. So all I'll do is just mark them around in there, just so I know roughly where those slots are. Now these bolts, 12 mil is not going to fit, so we'll make them 10. I'll drill probably 10.5 mils in the plate, but yeah, 10 mil will be good for that. Let's go back over to the mill. Righty, I've clamped it down. I should be able to get through all 3 holes and not drill into my 1, 2, 3 blocks onto there. It's all good and solid, not going to spin around and kill me. I've got my wobbly pointer in here again. I'll just start her up, centre that. There we go. Now I should be able to just line that up directly with my centre punch there. You find if you touch the surface and it's not in the middle, it'll make that wobble. You watch. Wouldn't you know it? I am right in the middle. Let's just kick it off a little bit. So you touch it and it wobbles. And we'll come back a bit. When you get it right, it just stays dead still when you touch it. so I can lock my table. This is going to be a bit of a combination. I've got a centre drill, a pilot drill, the actual size I want, which is 10.5, and then I'll chamfer it. So I'll show you one of those. You don't need to watch me do all three. I can go round now and do the other two holes, and I'll bring you back when that's done. Let's just reassemble that now. First thing we need to do is pop the screw back in there. That needs to slide down in there into the dovetail. It's a little bit of a balancing act to get it back in there. Well, that's got it. Next, I can pop that little pin back in there to hold the dovetail in so it can't fall out. Just like that. It's below that surface so it's not going to interfere anywhere. Next I can put the screw back in. Screw goes in, the spring goes on, then the washer. There we go. I can start that off in the nut there. Let's just put a bit of grease on that. God knows how long before someone looks at this again. A little bit on there, a little bit up on the screw. We'll wind it up and down a bit to spread it out. Now before I go all the way in, I just need to slide the spring and that washer back. Washer's still up here. There we go. And put that pin back in the hole. Should be able to see it in there. We've got that pin, the washer and the spring all in there nicely. Now the jaw will wind both ways again. Then we can put our new base on. It'll be that way around so the third hole lines up with our slot. So with that one down like that, we can see our holes. That one's got plenty of clearance. This one's could probably do with a fraction more clearance, but that's it's pretty good. I think we can call that fixed. I'm not going to bolt it down and test it. Thanks for watching, guys. Hope you got something out of this. Just shows you that you can pull something out of the fire. You don't need to throw things away. Use up things you got lying around the workshop. All I had to do was buy a couple of bolts. I had 3, but I really needed 4, so I had to go to the shop. Not often you hear of me going to the shop to buy something. Anyway, we can call that done. Thanks for watching, and we'll see you on the next one. I can't really see you.